we have an honored guest, Sawako Oiwa from Economic Research Laboratories in Japan. And she's been working with benchmarks and analysis of data from software projects and application development or application maintenance since more than 20 years back. She went from the Kyushu University after stopping there and get her degree. She went to the to the Economic Research Association 1991. And she's now responsible for an investigation team there. And they are focusing on data, as you can see, for software development and maintenance projects, and with a priority on productivity. And she is a certified function point specialist. And I'm looking forward to hear about this, about the benchmarking of projects and in Japan and how it works. Not only because I'm president of ISPC, I've also been working with benchmarking of projects within different kind of companies here up in the Nordic countries for 20 years. So I'm very familiar and really looking forward to this. So, very welcome, Sawako. And I would stop sharing now so you could start sharing your presentation. And very welcome.
Hello everyone, I'm Sawako Oiwa. I work for Economic Research Association. Today, I'd like to talk about benchmarking software project development projects in Japan. First of all, please let me introduce Economic Research Association. Economic Research Association was established in 1946. Our major business area is to analyze the prices of construction materials. A report including research results is published monthly. This report is often used for public procurement. In special fees, we started collecting project data in 2001. For these 20 years, we have collected over 2,000 project data. This slide shows today's topics. I have divided my presentation into 5 sections. First, I would like to talk about how to collect project data. Second, I would like to talk about outline of the report, analysis of software project data repository 2020. Third, overview of collected data. Fourth, I will show the analysis of FP productivity. Finally, I will show the analysis of FP failure density. Now, I would like to talk about how to collect project data. This slide shows how to collect project data. Main target of the survey is software development companies that belong to JSPUG. We make this survey once every year in the period from October to December. We send a questionnaire for this survey to the target companies by mail or email. The target companies can download it on Excel file via our website. The structure of the questionnaire is as follows. As shown in this slide, the questionnaire has 3 parts. Today, I would like to introduce the research results of part 3. Now, I would like to talk about outline of the report. In September 2020, we published new report, Analysis of Software Project State Repository 2020. Product detail is as shown. The report is free and you can download a PDF file via our website. The contents of the report are shown in this slide. Chapter 1 is outline of the survey. Chapter 2 is survey items and analysis policy. Chapter 3 is profiles of collected data. Chapter 4 is analysis of effort and development schedule. Chapter 5, analysis on sites. Chapter 6, analysis of sites, effort, and productivity. Chapter 7, analysis of effort by development process and effort by engineer. Chapter 8, analysis of reliability. Chapter 9, analysis of estimation and performance. Chapter 10, analysis of development price. Chapter 11, annual changes in survey items. Now I'm going to talk about overview of collected data. This graph shows types of system architecture. Web-based system forms the largest part of this graph. It occupies around 45% of all. This graph shows primary language of projects. As you may know, Java is the most popular language in Japan. This slide shows types of industry. Manufacturing has the largest part of this graph among all the types of industries. It occupies around 23% of all. Distribution is second largest. In this survey, distribution includes transportation, postal services, wholesale trade, and retail trade. This slide shows development schedule. The left axis shows number of projects, and right axis shows cumulative ratio. The horizontal axis shows development schedule of projects in month units. The interval is 2. As shown in this graph, most projects is carried out within 4 to 6 months. This slide shows development effort. The horizontal axis shows effort in person months. The interval is 20. As shown in this graph, most frequent effort lies under 20 person months. This slide shows the maximum effort expended by one person per month set by each company. One person month is the amount of time that one person expends for working on a software development project per 1 month. If a company employs 160 hours at the one person month, 800 hours is equal to 5 person months. In our survey, most companies use 160 hours per person month. This slide shows average effort ratio by development phase. Most largest part of this graph is software construction. It occupies around 40%. This slide shows functional size of all projects. As shown in this graph, 50% of the projects are less than 600 ST. This slide shows average function type ratio. As shown in this graph, date function occupies around 40%. This slide shows measurement method for function point count. The functional size is mostly measured using IFPUG method in Japan. This slide shows project size in SLOC units. As shown in this graph, 50% of the projects are less than 60 KLOC. Next, I'm going to show the analysis of FP productivity. This slide shows definition of FP productivity. FP productive is calculated by dividing the functional size by number of efforts. Unit of effort is person months. Efforts used for the analysis of FP productivity are the sum of effort expended in the phase. From system and software requirement analysis to system test. This graph shows the relationship between functional size and effort for development. As shown in this graph, the functional size and the effort have linear relationship. The survey examines conditions that affect productivity. This slide shows 3 items to examine the degree of the requirement. This slide shows an item to examine the degree of clarity and stability of the requirement. Now, I'm going to introduce the analysis of FP productivity by 4 conditions as shown. Firstly, one of the conditions is the level of functionality requirement of a user. The distribution of FP productivity for functionality requirement is shown in a box plot. As the degree of functionality requirement increases, FP productivity becomes lower. Second, the distribution of FP productivity for reliability requirements is shown in a box plot. As the degree of reliability requirement increases, FP productivity becomes lower. Third, the distribution of FP productivity for schedule requirements is shown in a box plot. When the shorter schedule is required, FP productivity tends to become lower. Fourth, the distribution of FP productivity for the degree of clarity and stability of requirement is shown in a box plot. When the requirements are not clear, FP productivity tends to be lower. Now, I'm going to show the analysis of FP failure density. This slide shows definition of FP failure density. Failure count is the number of failures during the first 3 months after delivery. The FP failure density is calculated by dividing failure count by functional size, and convert it to 1000 FE. Now, I'm going to show the analysis of FP failure density by four conditions as same as the analysis of FP productivity. Firstly, the distribution of FP failure density by functional requirement is shown in a box plot. As the degree of functionality requirement increases, FP failure density tends to become higher. Second, the distribution of FP failure density by reliability requirement is shown in a box plot. As the degree of reliability requirement increases, FP failure density tends to become higher. Third, the distribution of the FP failure density by the schedule requirement is shown in a box plot. When the schedule requirement is as expected, FP failure densities tend to become low. Fourth, the distribution of FP failure density by the degree of clarity and stability of requirement is shown in a box plot. When the requirements are not clear, the FP failure density tends to be higher. Comparing the analysis of FP productivity and the analysis of FP failure density, we can find that there is a trade-off between each. That's all for my presentation. If you want to see other analysis, please download the report via our website. I'm sorry for our website only Japanese. So I would like to introduce how to download the report. Firstly, please access our website and click here for moving to the next page. In this page, we ask about you. These are two questions. Please select Others posts and click here for moving to the next page. This page is to confirm your answer. Please click here for moving to the next page. This is final page for download. Please click here. You can download the report. I'm sorry, the report is available only in Japanese. So I am translating partly into English, chapter 1, chapter 2, and chapter 3. I will offer the file after my webinar to host. That's all my presentation. Thank you for your attention. If you have any questions, please email me. Mail address is here. Please understand, email text should be English. Furthermore, email in Japanese is most welcome. Thank you.